Welcome to the Deep Dive. We're here to take, well, a really dense and complicated field, break it down, and give you the key insights you need. Today, we're diving into the tech that teaches computers to see. We're talking computer vision, or CV.
That's right.
Our sources cover the basics, the cutting-edge stuff, and where it's all heading. Our mission, it's pretty clear. We want to figure out how machines turn pixels, just raw visual data, into actual understanding and action. And, what that means for all of us down the line.
Exactly. And maybe we should just start with a quick definition.
Yeah, good idea.
So, computer vision. It's essentially the branch of AI that gives machines the power to interpret, to understand visual information.
Like photos, videos.
Right. Static images, video feeds, data from sensors.
Yeah.
It's all about turning that camera from just a passive lens into something that, well, intelligently observes.
An active observer. Okay.
And it's important to grasp the scale here. CV isn't some future tech. It's already driving systems everywhere. Healthcare, transport.
Billions of dollars in autonomous driving, our notes mentioned.
Exactly. So the really fascinating part is digging into how it bridges that gap, from just light hitting a sensor to something like human visual intelligence.
Okay, let's definitely unpack that. Let's get into the nuts and bolts beyond just saying AI.
Right.
So imagine a complex scene. A busy street corner, maybe.
Mhm.
Changing light, shadows, lots of things moving.
Mm.
How do we actually train a machine to reliably spot something specific, like, say, a pedestrian who's partly hidden?
Yeah, that complexity, handling that relies almost entirely on deep learning algorithms.
Okay.
Specifically, something called convolutional neural networks, or CNNs. They're really the workhorses of modern CV.
Why CNN specifically?
Because they're built for hierarchical feature extraction. It's quite clever, actually. They don't just look at the whole image at once and guess. It's more like building blocks.
Okay.
So the initial layers in the network, they learn to spot really simple things. Edges, corners, maybe basic color shifts, gradients.
Like the absolute basics of vision.
Exactly. Then, as the data goes deeper into the network, these simple features get combined. They start forming more complex shapes, textures, and eventually you get to high-level concepts, things like recognizing a face or the shape of a car.
So it learns the parts to understand the whole. Like it learns green and it learns the shape of a traffic light and puts them together.
Precisely.
But this learning, it needs a huge amount of data, right? Our note said millions of examples. How massive are we talking? And maybe more importantly, where does all that perfectly labeled data come from?
Yeah. That's probably the biggest practical challenge in CV today, creating what we call the ground truth.
Ground truth?
Yeah, the labeled data. For systems where accuracy is critical, think surgery robots or self-driving cars, you need incredibly high accuracy.
Right.
Which means almost every object in those millions of training images needs to be manually tagged, labeled.
By people.
Mostly, yes, or at least verified by people. And think about the detail needed. Object detection might just be drawing a box around a person. Simple enough. But for something like image segmentation, which you absolutely need if a robot has to interact physically with the world, you have to label every single pixel that belongs to that person.
Every pixel, wow.
Yeah. The amount of human effort, the time, the sheer cost involved in labeling these massive data sets, it's immense. It's kind of the hidden engine driving machine vision.
That really changes the perspective. It's not just complex math, it's this massive data preparation job. Okay, so once we have all that labeled data, let's walk through the process for the listener.
Yeah.
How does the machine see and respond? It's a loop, right?
Exactly. It's a sequence.
So first step, data acquisition.
Mm-hmm.
The camera captures the image.
Right.
Step 2, clean it up, enhance it, get rid of noise.
Pre-processing, yeah. Crucial.
Third, feature detection. The neural network finds those key bits, edges, shapes, like you said. Fourth, classification. It figures out, okay, those shapes and edges mean pedestrian.
Yep, identifying what's there.
And finally, fifth, decision time. Based on identifying that pedestrian, the system decides what to do. For a self-driving car, that probably means hitting the brakes or slowing down.
Precisely. And it's that decision-making part, especially when dealing with live video streams, that makes CV more than just pattern recognition. It becomes a decision engine.
And it has to happen instantly.
Instantly. And that capability is why CV is already transforming so many industries right now.
Okay, so let's pivot from the mechanics to where it's actually working today. You mentioned precision being key.
Yes. Let's look at some specific, tangible uses.
Transportation comes up constantly. Autonomous vehicles, right? CV is basically essential for them to navigate safely.
Non-negotiable, really. But it's important to remember it's not just one magic sensor. It's a whole system dealing with incredible variability.
So it's using cameras, maybe LiDAR too?
Often a combination, yes.
Yeah.
Processing all that input to not just detect traffic or pedestrians or signs,
Yeah.
but also to predict their likely movements. Even when the conditions are bad, like heavy rain or bright sun glare, or if something's partially blocked from view.
That sounds like intense, constant calculation, high stakes.
Extremely high stakes. It's all about probabilities, constantly updated.
Yeah.
And that need for reliability, for hyperaccuracy, leads us to other precision fields,
Hmm.
like healthcare.
Right, you mentioned that earlier. Analyzing medical scans.
Yes, things like MRIs, CT scans, even images of the retina. CV algorithms are being trained to spot signs of disease, sometimes much earlier or more consistently than a human might, especially, avoiding issues of fatigue for radiologists.
Can you give a specific example?
Sure. A really good one is in ophthalmology detecting diabetic retinopathy.
Okay.
This condition causes tiny little changes in the retina, like microaneurysms or small hemorrhages. They can be hard to spot early on. But CV systems, trained on, again, millions of examples, can learn to reliably detect these tiny early warning signs. Signs a human might miss until the disease is more advanced. That's potentially sight-saving, a real game changer for preventative medicine.
Wow. It's fascinating to see that range from huge self-driving systems ensuring road safety down to spotting microscopic changes for individual health.
Mm-hmm.
And then there's the everyday stuff,
Yeah.
things we might not even think of as CV.
Absolutely. It's becoming embedded in consumer tech we use all the time.
Our notes mention things like visual search apps. Point your phone at a plant and it tells you what it is.
That's CV, or pointing it at a building, yeah.
Yep.
Instant identification based on the image.
And what about those cashierless stores that are popping up?
Prime example. They rely almost entirely on CV. Cameras track everything you pick up, everything you put back, purely through visual recognition, in real time.
Tracking every item, linking it to you.
Exactly. It demonstrates the sheer processing power needed. Handling multiple video streams, identifying hundreds of different products instantly, mapping them to specific shoppers. It's computationally intense.
It really highlights how this tech is quietly weaving itself into our daily lives.
That's why we say it's fundamentally reshaping the world around us, often without us noticing.
Okay, this is where I think it gets really exciting looking ahead. We've talked about how CV classifies things. That's a stop sign. But the future seems to be moving beyond just seeing towards, well, understanding.
Yes, that shift from seeing to understanding is the next big leap. It's about context.
Context.
Yeah, so a current system might identify, say, two people in an image. A future system aims to understand that those two people are shaking hands, or maybe they're arguing or working together on a specific task, understanding the interaction, the scene dynamics.
How does that play out in fields like healthcare?
Well, think beyond static scans. Imagine CV analyzing video maybe of how a patient walks, their gait, over several weeks. It could potentially detect subtle changes, tiny indicators of neurological decline, maybe Parkinson's, long before the patient or doctor would notice subjective symptoms. It shifts personalized medicine from being reactive to being incredibly proactive.
That's powerful. And connecting that to the bigger picture of smart cities.
Foundational, absolutely foundational for truly smart cities. It's not just about counting cars anymore.
Right.
It's about analyzing complex traffic flows, density patterns, using that visual understanding to dynamically adjust traffic light timings, maybe predict accident hotspots based on analyzing near misses from video, or deploy emergency services more efficiently.
Using vision to optimize the whole system.
Exactly. And we absolutely cannot forget the accessibility angle. This is huge.
How so?
For visually impaired users, CV can process the visual world around them and translate it into real-time audio descriptions.
So not just there's a cup.
No, much more. There's a coffee cup on the table to your left, near the edge, providing immediate, useful context about objects, potential obstacles, maybe even social cues like who is looking at them. It can offer a new level of independence.
That's incredible. So the ultimate goal seems to be replicating, maybe even exceeding, the contextual richness of human sight.
That's the direction. As the tech gets better, the line blurs. Machines won't just see pixels or label objects. They'll start to genuinely understand the visual world, the context, the movement, maybe even inferring intent.
Okay, so let's try to wrap this up. A quick summary.
Sure. We started with the challenge, right? The massive effort needed to train these systems with millions of carefully labeled examples, that crucial ground truth.
Mm-hmm.
Then we saw its current impact enabling safety and autonomous systems, bringing new precision to medical diagnosis.
Right. And the connection back to you, the listener, is pretty direct. This isn't sci-fi anymore.
Not at all.
CV is already influencing things around you. How reliable a medical diagnosis might be, how traffic flows on your commute, even how you shop. You're already living in a world shaped by computer vision.
Definitely. So maybe here's a final thought to mull over, building on that idea of machines moving towards understanding.
Okay, let's hear it.
Well, if we accept that CV's core aim is to bridge the gap between how humans see and how machines interpret, what new questions, practical or even ethical, pop up when a machine's understanding of what it sees becomes the basis for making really high-stakes decisions
Decisions
about things like dynamically routing city traffic, potentially prioritizing certain vehicles, or even recommending a specific medical treatment path based purely on its visual assessment. When the machine's interpretation holds that much weight, what does that mean for us?
that shift in who or what is doing the understanding and the deciding. Yeah, that is definitely
Yeah.
something worth thinking about.